The warm springs of Pointe-à-Pierre are one of the local geological items that are hard to confirm, as few persons may still be alive who have personally seen them. This map shows the location of major faults in Trinidad. The Warm Springs Fault in central Trinidad is highlighted in orange. This is an oblique Google Earth view to the west of the entire trace of the Warm Springs Fault. We see that a number of settlements have sprung up along its path. Let's start with how the fault got its name. These two springs were first described by E.L. Joseph on page 24 of his book, The History of Trinidad, published in 1838. The next mention is by Duvertile on page 89 of his book, published in 1858. In it, he describes three springs together with the analyses of the water. Wall and Sawkins, in their 1860 publication, Report on the Geology of Trinidad on page 200, gave a detailed description of two springs, one of which was used for bathing. Waring, in his 1926 PhD thesis, on page 121, describes several springs. He also calculated that this water may be rising from a depth of 1,400 feet. Kugler, in a 1939 field trip guide, illustrated the location of the fault. In a geological cross-section from the same document, the fault was called the Hot Springs Fault, not Warm Springs. Suter in 1951 describes one hot spring and gave analysis of the water. He also indicates that this water is originating from depths of around 3,000 feet. There are no other references to the hot or warm springs in the literature after 1951. So where exactly are these springs? The 1 in 5,000 geological spot map for the Pointe-à-Pierre area puts them on either side of the Warm Springs Fault in the Plaisance Park Industrial Estate area. Here, the very sandy Caparo clay member outcrops and abuts against the Warm Springs Fault. This 1959 geological cross-section gives an updated cross-sectional view of the area, and it shows that the fault dips to the north. In this video, we get a 360-degree panoramic view of the area around the Plaisance Industrial Estate, starting with the Point Lisas Industrial Estate in the north and moving south to Pointe-à-Pierre and eventually back to Point Lisas. The Warm Springs Fault corresponds to the narrow area of vegetation between the buildings and extends from south to north across the photo. Next, we go to the Macaulay area close to the Sir Solomon Hojoy Highway. Note that the fault is not mapped as a continuous one and is displaced in two areas. In this drone photo, we have put in the trace of the Warm Springs Fault where it separates the Talparo from the Brasso sediments. In January 2016, we are looking east towards the Macaulay Government Primary School. The new school foundation straddles the Warm Springs Fault. On the right are seen dark grey Brasso clay stones, and on the left are sands of the Talparo. Here we see the fault contact between the sulfur-stained and mottled Talparo sand and the iron oxide-stained Brasso claystone beds. The apparent dip of the fault plane is to the south. Here we see a close-up of the fault contact and the fractured sandstones on the right. Here we see steeply dipping fractured Brasso claystones. Here we see highly faulted sands of the Talparo located to the southwest of the school construction site. So what is the impact of the Warm Springs and the associated Central Range Fault? This map shows that areas to the north of the Central Range are moving eastward faster than areas to the south, and they are separated by the Warm Springs Central Range Fault Zone. In this map of earthquake locations for Trinidad by Latchman in 2011, it shows that most of the earthquakes take place north of the Central Range because it is part of the fast-moving Caribbean Plate. Areas to the south of the Central Range have few earthquakes because it is on the slower moving South American Plate.